At Dave Cooper Live, we connect the industry leaders in the architectural, engineering, and construction space with the people, the products, and the processes to help them build it better.
All right. Ever wonder how robotic microfactories are transforming the home building industry? Well, you're in for a treat today. Enti, Vikas, co-founder and CEO of his ex-Amazon team, are pioneering the construction of net zero homes using cutting-edge robotic microfactories. Welcome, everybody, to Dave Cooper Live, where we connect the industry leaders in the AEC space with the people, the products, and the processes to help them build it better. Vikas Enti, co-founder and CEO of Reframe Systems, is shifting the complexity of home building into their proprietary software, creating digital work instructions for CNCs, robots, and builders. This innovative approach addresses regional building codes and styles, making the construction process more efficient and cost-effective. Stay tuned to find out why Vikas and his team believe we cannot build homes the same way we build cars today. This is going to be an eye-opening conversation you're not going to want to miss. But first, a word from our sponsor.
Stream Modular, the only logistics company you need to transport your mods, pods, and panels. Our friends at Stream Modular are investing $50 million over the next 25 years to build the technology, solutions, and trailers needed to handle and transport the projects of today and meet the demands of tomorrow. Reach out to their team at streammodular.com to discuss your next project. CombiLift is the largest global manufacturer of multi-directional forklifts and straddle carriers, a leader in long load handling solutions, offering a free warehouse and site optimization design service. CombiLift helps companies of all sizes and from every industry maximize the capacity, safety, and efficiency of their warehouse and storage facilities. A big thank you to Paul Short and the team at CombiLift for helping us all to build it better. Visit them at combilift.com. Ready to scale up your offsite construction business? Introducing 4A Constructs, your solution to finding skilled labor for offsite manufacturing. Say goodbye to the headache of recruiting a skilled workforce with hand-selected certified tradesmen that are expertly trained and managed for offsite manufacturing, set crews, and finish crews, ensuring maximum productivity and safety. Unlock the future of skilled workforce development for all of your offsite construction needs. Visit them at 4aconstructs.com.
All right, again, a big thank you to all of our supporting members and sponsors out there, and a big shout out to Shawn Intagliata, Cobalt Creed, for powering all of these episodes as well. I'm Dave Cooper, and we're going to have a great show for you, so let's hop into it. Without further ado, let's bring on Vikas Enti, Reframe Systems. Vikas, welcome to the show, my friend.
Hey, Dave. Thank you so much for having me on.
Well, I love what you guys are doing. We met at the Housing Innovative Showcase in Washington, D.C. on the mall. And by the way, we met a lot of awesome stuff down there. For those of you who didn't attend last year, you need to attend, or this year, I should say, you should attend next year. But hey, Vikas, before we hop into your innovative way of building with your microfactories, we want to know everything about you from the moment you were born to this very moment in time. Do not leave out any of the good stuff from the hospital, or we will have a family member on or a team member, because I know of one of them pretty well. But you only have a minute and a half to do it. So the floor is yours.
All right, I'll do my best here. So I was born and raised in Bangalore, India. Was there till I was 15. Moved to Singapore for my high school, and then ended up in upstate New York for college. And it's been a wonderful journey to date, where I was really able to explore a lot of my childhood hobbies around building and tearing things apart through becoming an engineer in college, where I really started to focus on mobile robotics as a space. Got my hands pretty deep into the space of building humanitarian demining robots. And then after college, I had a stint doing robotics research in Singapore, and then moved back to the US, where I joined this company called Kiva Systems up in Boston. That company eventually was bought by Amazon and became Amazon Robotics, and we'll speak more about why that matters. And along that journey, I eventually settled down in the Boston area, became a new dad, a proud dad of 3-year-old twin girls. They are my inspiration. They're the reason Reframe Systems exists. Becoming a new dad, I think, was that catalyzing moment where I think I had the most amount of clarity in terms of how I wanted to spend the next stage of my career. And a lot of the focus has been on how do we start solving two of the biggest challenges that face society today, being the housing shortage and the climate crisis. And we believe we've somehow got lucky in intersecting both of those problems with the work we're doing at Reframe. It's good to be on the show, and I appreciate having me.
Hey, listen, we're twinners, right? I got twins as well, so I know the pain, and I know the glory and the fun and the excitement of having twins once you get through those first year or two, when they're born. But that's awesome. Congratulations on that. And everybody that I speak to, Vikas, always has a purpose, right? There's always a reason internally, and hearing that story about when your twins were born, and just having this passion to do something better for the industry and help solve the ever eluding housing crisis that so many are trying to really come after. I'm excited to talk about everything you have going here. So before we jump into this, talk to me a little bit about what is the core mission of Reframe Systems, and truly, how does it differentiate itself from how others are building using offsite construction methods?
Absolutely. For Reframe, our mission's pretty simple, which is how do we unlock net zero homes for all? And there's a lot packed into that. I think the first piece there is how do we get more homes produced? And to do that, right, we have a very differentiated industrialization approach that I'll get into a lot more detail in a little bit. But the other piece that I think is equally important is how do we make sure that the homes we build today are not just good and healthy for people, but they're also healthy for the planet. And surprisingly, homes that are healthy for the planet can also be healthy for your wallet. And I think that's been really a really nice intersection of how we've been able to converge in our mission, but also make sure it's highly valuable for our customers.
Well, I know you have a presentation that we're going to get through here, so why don't we hop into it? Walk us through this. We have some videos that's going to show your process, the factory, and some product that has actually been built and hopefully people are living in. So let's hop into it. I'll put your presentation up on the screen for you. Sound like a plan?
Excellent. Let's do this.
All right.
All right. So as I said, Reframe Systems, our mission is to build and unlock net zero homes for all. And the primary way we're doing it differently is in our approach for industrialized construction. Here, we're taking a very software-centric approach where we transform construction processes into software-driven manufacturing. And we package these into a slightly different, smaller footprint factory model that I'll talk about. And we love using robots where they're applicable, and they're a key part of our story, but we're not a robotics company. And I want to make sure we call that out. So a little bit more background of the company itself. You mentioned this before. My co-founders and I, we've had a pretty long stint at Amazon Robotics, where we got to build out. In fact, I was there to build out from the first robotic fulfillment center Amazon had till about 70 of those while I left. So about 500,000 robots deployed in the world. And a lot of you get to experience same day shipping or next day shipping. A lot of this was the work we were doing in building out the fulfillment infrastructure, installation infrastructure. Over that time, we learned a thing or two in how do we scale processes, and we learned very quickly that software becomes a key aspect that allows you to scale your systems and then actually get to global scale. And a lot of those principles are true and kind of live on in how we approach the problems at Reframe. We're still very early in our journey, 20 months old, almost getting close to becoming 2 years soon. And we're already delivering homes to paying customers. We're about a team of 25 today based out of Andover, Massachusetts. This is where our first microfactory is operational. And yeah, excited to show you more about how we got here. So the real focus, and I think this will be a constant theme, and I'm sure this comes across in every video that we've had on the show, because we're all trying to figure out how we solve for the skilled labor shortage. And I think the skilled piece is a key operating word here. Because if you look back in time, and I think I have data here that goes back to 1990 and how we're controlling for inflation versus building cost versus material cost, the cost of skilled labor has just outpaced the cost of materials, and overall has been the heavyweight component for cost of construction. And this is incredibly important because as we've looked through a lot of invoice level data to other construction costs broken down, it almost always lands at a 50-50% between cost of materials versus cost of labor. So we truly believe that we have to find a way to improve labor productivity so we can make sure that the skilled labor that we have access to is actually able to produce a lot more homes. And the reason that productivity perspective is super important is because we already have about 500,000 skilled labor worker shortage in the US today. And what's scarier is the fact that 40% of them are set to retire in the next 10 years. And we're having a huge challenge bringing apprentices into the industry. So we need to find a different approach for improving the skill level in the industry, but finding a path that allows us to bring a new workforce that's actually able to produce homes at the quality that the skilled workforce is able to. And that's been like a key question for us, is like, how do we unlock that? And if we don't do this, we're already at a risk of, right, depending on whose statistic you use, right, 3.2 million to 7 million units of housing shortage in the US. That actually translates to needing to build about a home every 15 seconds. And if we don't industrialize the process and don't improve labor productivity, we're actually going to be in a lot more trouble. And that's been like the key focus question on how do we make sure we're improving processes to get there. And to do that, we always hear about industrialization, and I'm sure you've heard this time and again, which is, hey, like, we need to build homes the way we build cars. Like, that's the only way to drive costs down. Well, there's some truth to that, and that we need to industrialize the process to make sure we get efficiencies. I think there's a huge distinction between mass production, the approach that's taken place for building cars and other manufactured products, versus the approach of mass customization, which is what we need for producing homes. And mass customization here isn't also about, hey, we really need to cater to build custom homes because people have a lot of preferences on floor plans. This actually has to do with just building homes that are legal. How do you make sure you're able to deal with all the variations that exist, from climate zones to building codes to site conditions? And the most dangerous one of all in the US are zoning conditions, like zoning laws. We have about 30,000 zoning jurisdictions in the country where a building could be perfectly legal, which meets site conditions, building codes, but zoning laws we found are very arbitrary. They have language that says it has to meet the look and feel of a neighborhood, and all of a sudden you're having to redesign the fenestration ratio of your buildings or redesign the roof line to do that. So we know that it's going to be a hard battle to fight that. I know a lot of them in the industry are pushing for, we need to standardize the product. We argue that you have to standardize the platform, but the way you can customize the platform so you can build homes that actually are compliant for zoning is the only way you can actually scale production. And to do that, current systems aren't really built out for it, because most systems today are built off of the Ford model, which was, right, that you can have any color as you want as long as it's black. Like, that's the model we've been building a lot of mass production and lean manufacturing around. But to solve the problem for housing, you actually have to twist that to be more, to actually embrace the customization requirements. And the other challenge where applying the mass production model actually breaks for housing is the production uncertainty that exists. The housing market operates in a feast or famine mode. Sometimes it's because of market cycles on the macro scale, but on a local scale, just the uncertainty you have from permitting to zoning to financing timelines, most projects slip even before they get to the factory. So how do you actually operate a production environment not knowing when you have to build to order? The mass production world, you build to stocks, you're actually able to say, we're going to build. You get to set your targets and build to targets. But in the housing production, where you're having to react to your customer project slipping, that's a very different challenge. But these challenges actually map really nicely to the challenges we solved in the e-commerce world. Like the reason the Amazon connection is important here is in the e-commerce world, one, we don't tell a customer you can only buy a certain product. Like you can pick a red pen, blue pen, and a teddy bear. And the job of the software and the fulfillment system behind the scenes is to make sure all of those items get into the same box for the same amount of time and for a known cost. So we built systems to embrace the selection and customization that customers want, but doing it in a way where the actual process of doing it is standardized, right? Like a person's always having to perform the same task to pick something. Instructions for that person are very, very clear. Mm-hmm. And we're trying to bring a lot of those principles, and we believe that's actually the right framework to apply. So we should actually be saying we should be building homes the way Amazon fulfills orders. That probably becomes a way to actually unlock this future. And to do that, right, a lot of the times when people look at Amazon from the outside, they say, hey, Amazon is successful in really getting the speed and scale because they have robots. Well, that's partly true. The real reason we were able to scale is actually getting to this whole end-to-end software-driven fulfillment, like software-driven orchestration, where software controls the entire experience from a customer placing an order on a website all the way to this order actually getting distributed into the fulfillment center, getting instructions that go automatically to the robots, instructions that go to the people, and finally how it actually gets instructions to the supply chain and the delivery services to make sure it gets delivered. And this whole end-to-end software coordination is what allows the system to embrace the difference in order profiles that come in, the different type of orders, the different selection sets, dealing with all the different transportation networks. So I think like software is super important. And we found that while there's a lot of different approaches to developing the software in the offsite construction industry, it's still very rigid. And I think there's a lot of room here for us to embrace software to go end to end. And the other thing I would also argue is the single most powerful thing for Amazon's arsenal was this screen here that you see the person looking at. Like that screen allowed Amazon to hire people in the morning and have them be operating at learning curve by end of the day, because that really simplified the instructions. It allowed them to really not need to be trained beforehand. And I think there's a lot of merit to that approach, where could we apply the same approach for bringing apprentices into construction, but actually have them perform as highly skilled builders really quickly. And that's the same approach we're applying here at Reframe. Like, how do we treat this as a software-driven manufacturing problem? So we're building what we call the Reframe operating system. Internally, the team loves to call it the Reframe mainframe. And so we're still working on our branding exercise there. But the whole goal is how do we build, starting from a highly parametric digital model of our building platform, which can then be customized to become a project. And when it becomes a project, it's actually accepting inputs regarding building codes, zoning codes, to actually make sure we can customize the right dimensions or choose the right roof line. So a lot of this work's already happening in the software world, and we're not creating any paper output so far. And once we actually confirm on the project we want to build, the software we've developed actually allows us to then create the instructions that automatically go to our robots, go to our CNC machines, but more importantly, actually go to the workforce we have in the factory. Currently, we have almost a ratio of a 50% apprentice to 50% skilled builders in our team. And this has been a great way for us to actually learn to keep improving our software and also understand the right level of instructions we have to provide on the screen. And I want to be able to clarify that a lot of times when people think about work instructions on a screen, they're assuming that it's just a digital version of a paper drawing. And that this is very far from the truth, right? The analogy I can give you is, if you think about how we use navigation systems today for driving, we've moved from paper-based maps to digital maps you would look at on the computer that you still print out, to finally getting turn-by-turn instructions. we feel like a lot of the industry has actually moved to the digital instruction. You still see a paper drawing on a screen. What we're trying to get to is how do we get inspiration from IKEA manuals and Lego assembly instruction manuals. So they were actually showing step-by-step instructions that anyone who is motivated enough can actually look at the screen and put stuff together. And we're trying to break our system down to those level of instructions. We believe that's what's going to give us the ability to scale and actually bridge the skill labor gap. And with that, we've kind of set a bunch of rules that allowed us to rethink the solution. Right. The first thing we observed in the industry was because people are trying to get to this mass production approach, it pretty much led to saying you need to have these large regional factories that have to be able to spit out 1 million square feet or 5 million square feet of product a year. The challenge is really hard to keep those factories busy all the time. So we said we have to be able to build smaller footprint, low cost factories, right? So our micro factories that we can deploy quickly across the country. We just spoke about the paper drawings. How do we go away from paper drawings to step-by-step instructions that we can actually reduce the true skill level needed on day one so that we can actually bring more people into the workforce and actually have them be very productive. And we have this rule about no tape measures. If you think about manufacturing, right, and one place the car manufacturing analogy works is you don't see a person pulling a tape measure when assembling a car. But why do we still do that? Even in the most automated home building factory, that we still have this notion of having tape measures, right? So we're trying to get to a world where how do we pre-process material, but also print instructions on the material directly? So we're reducing the need for additional need for tape measures and cutting. And the last thing is no conveyor. Like conveyor was a 4-letter word in my previous role with Kiva Systems and Amazon Robotics. So that the moment you have conveyor systems in a building, you're constraining the facility. Like you're actually bolting automation down, you're bolting material handling equipment down. That really constrains the layout of the factory, and you're having to plan for throughput that's 5 years down the line. So our whole goal is how do you build flexible decoupled systems that, right? So almost everything in our factory is on wheels. So we have this very simple thing called a panel cart, where we build everything as a panel in our factory before it becomes a volumetric module. But instead of building a panel horizontally, which then has to go on a flat conveyor, we build our panels vertically. They stay on these panel cars so they can roll them around. And this has given us a lot of flexibility in how we rethink the layout of our factory. And maybe this is a good place to pop up the other video. So we've packaged all of this work into a small footprint micro factory where we can go from the whole digital design model I spoke about to a factory where we use a mix of robots to take care of framing and sheathing. This is our own proprietary robotic system. What's different here is the robot's actually scanning for barcodes on the studs. We're building additional algorithms to allow us to get the same behavior a master carpenter uses for twisting bent studs into place before nailing them. The robot's able to regrasp studs to make sure we get stuff in play. And that's a huge unlock for us, so we can use studs that we buy off of our local lumber yard to be able to build our homes. We spoke about the mobile panel carts. A lot of our carpenters use iPads, but the step-by-step instructions go one level further, where we already have GPT integration, so you don't have to read a whole instruction manual. You can actually get the data points you need. And stuff we're prototyping is, can we have these desktop workstations that allow you to do more complex assemblies in there? And the last thing that's important, maybe let me pause the video here for a second. I think we'd love for the industry to emulate more of this, is this whole aspect of these desktop workstations for taking care of sub-assemblies, right? Like, why do we have to spend all this time crouching under a sink to get all the connectors behind the faucet done? Like, why don't we pre-kit that? Same thing for a water heater. Even when you're building a wet wall, like, why do we have to, right, measure pipe, cut pipe, make the convex connections, like, while we're trying to get the wet wall assembly? Our whole goal is, can we pre-kit a lot of these components using desktop stations? And this, again, gives you much greater control in getting instructions to your builder. So here we also have integration of light-guided instructions. There's a depth camera looking down, so we can actually do inline quality control and we pick the right components. And the other part that's critical to our model is where we pre-build everything as a finished panel before it becomes a volumetric module. And that is a huge advantage for footprint. The reason we can actually reduce the size of our buildings is this portion right here, where every volumetric modular factory in the world has a propensity, even if they build panels separately on a panel and floors on a floor line, they have this desire to marry the floor and the walls as soon as they can, so they can get a 6-sided box as early as they can in their process. And now you're stuck with 10,000 or 20,000 square feet of factory space just to move this box around for 14 days before it becomes a module that you can ship. In our world, we said, what if we pre-build all the wall panels first, pre-finish the wall panels? We're exploring bathroom pods as a way to pre-finish those components. Build the floor cassette last. And then can you go from floor cassette to a finished module in less than 2 days? And that approach is what's allowing us to make sure that in our factory, less than 20% of the factory space reserved for volumetric modules. Everything else is on panelized line. And this is how we actually get to shrink our factory footprint while still being able to maintain similar throughput as what the industry's at. And
Wow.
that's been a huge unlock for us. I know I've kind of gone on a pretty long talk here. Happy to pause here, take some questions, then we can talk a little bit more about our projects.
Yeah. So my question is, if you're building full completed panels, I mean, that's MEPs, everything in the wall panel?
That's correct. So we have MEPs in the wall panel, and that's been a key part of how do we unlock a lot of the productivity gains at the modular integration step. Otherwise, it takes up a lot of time trying to get all of your wiring and plumbing done at that stage.
And are you using any proprietary systems for that, low voltage wiring systems? How are you making the connection points? Or are they your typical quick connects?
One requirement we had for the design team is how do we make sure that all the components we specify are things we can drive up to a local Home Depot and buy in case we run out of stuff. And that's been a really clarifying decision for us. So no proprietary connectors. In fact, even for wiring, we're actually leaving a lot of the way we do wiring. I should actually correct my statement. We have a multi-trade wall, but we're actually just having conduits for the electrical. Mm-hmm. So we still add the final wires once the ceiling's done. Like all the wire spools are actually in the ceiling. And then we drop them into the walls at integration. So that way we're eliminating the need for connectors. Like we've done previous prototypes where we used connectors for low voltage systems that we could actually make connections and actually leave them in the wall. We saw it actually adding cost to our bill of materials, but also it raised this question for us on 5 years down the line, if there's an issue with the unit, will the electrician who's actually fixing the unit know that there's a connector behind the wall? Like, how will they fix it? So that question led us to say, for a lot of our customers, it's mostly a built-to-rental property. Right. Maintenance is important. Like, how do we make sure we're still using systems that the industry understands really well? So there's absolutely nothing fancy in those systems in our usage today.
And you're doing pre-assembly of the systems before they go on the wall? Are you doing that in-house, or do you have the pre-assembly done and then brought in?
Today we're doing them in-house. I expect that when we get to scale, this is an obvious place that we can find tier 1 suppliers to actually help us take care of wiring harnesses, as an example. Even trying to get some more, I'd say, part of our plumbing pre-done. I think there's an opportunity there. There's also an opportunity just for us in our network where we might. Today, our goal is how do we replicate these microfactories that are self-contained in metropolitan markets. Mm-hmm. Over time, I could see a case where we're actually building regional hubs that can supply these microfactories so we can pull some more of those things into a centralized manner. So this is an evolving topic for us. But if there are suppliers who are on this call or on this video listening, we'd love to find ways to work with more efficient supply chains. If you're already pre-kitting these systems, and we'd be happy to talk to you.
Yeah, for sure. Average size of a microfactory. I mean, what have you found size-wise to get, the throughput you're looking for?
So we believe we need to get closer to a 40 to 50,000 square foot footprint. The first microfactory we have is actually 16,000 square feet. We can produce about 45,000 square feet of modules a year from this factory, and we still have surplus capacity for panels. So we're looking for partners to actually deploy panels into panelized construction with them. But the sweet spot for us is if we find a 40 to 50,000 square foot factory, that's where we believe we can actually start getting to the 500,000 square feet of volumetric modules a year. And that becomes a really interesting play where we can actually start taking on more of the 24 to 30 unit type garden style multifamily projects and do more of them. So that's the sweet spot we're going to. And this 50,000 square foot number is actually a deliberate target too. Some of the earned experience from Amazon was when you try to look for real estate smaller than that size, you're actually 3 times more likely to find a space you can occupy with short-term leases within an hour of a metropolitan area versus going larger than the number. The moment you exceed the 50,000 square foot, you're starting to look for more 10-year type leases or places you have to end up switching to build to suit. So we believe that 50,000 square foot number actually allows us to get to new markets quickly.
How many employees in a factory for that size factory? So once you have all the processes in place, the equipment in place, what does it really take, from a labor perspective to run that manufacturing?
That's a really good question. So it's going to be a multi-year roadmap. Today, we are effectively at about 18 to 20 labor minutes a square foot in terms of our productivity. we want to be able to bring that number down to about 6 labor minutes a square foot. And we have a roadmap that allows us to do that from the industrialization processes to the automation systems we're bringing in. At that scale, you're basically looking at a team of 30 to 50, right, in this 50,000 square foot factory that's producing 500,000 square feet. And we believe like that actually becomes a really interesting ratio where not only do you have low fixed costs for the factory, but you also have low operating costs, which allows you to, even at 20% utilization of the factory, you're able to be cash flow positive. And that's one way for us to deal with the feast and famine cycles we see in the industry. So we've been really deliberate about sizing for them.
Yeah, and I'm going to save this question, but I'm going to tee it up right now. You know, what does it cost to get one of these up and running? But I think first, why don't we finish your presentation?
Sure. Yeah, so we spoke about the factory. I want to speak just a little bit about how we're using the factory and how we retooled our building platform to be able to work with this factory. Briefly mentioned that we're effectively running a panelized operation until the very last step before it becomes a volumetric module. But even the way the panels are designed and coded, we've been building some proprietary systems within Onshape as a CAD platform that allows us to stay in the parametric world. And every component we're designing is parameterized so that we can actually write software to reconfigure a building rather than have a person kind of redesign stuff with the mouse, right? So that's been a requirement for the design automation team, is how do we have software generate the designs. And we've been very deliberate about some of the material choices in our building platform, right? Getting to net zero energy is really well understood, right? But trying to get to that with low embodied carbon is a bigger challenge. And we're learning more and more that the amount of carbon we're putting out today is going to have a much bigger impact than carbon we're going to put out 20 years from now. So we also be really mindful of choosing low embodied carbon materials. And to do that, we've just jump back, and I'll jump back to it. So we made a few choices, and this is evident in our first customer project. Right from reducing the amount of concrete we need, like as a modular builder, the other thing that's different for us is we take ownership with our customers to go from foundation to finish. Mm-hmm. So we serve as a single contractor for them. So it allows us to make a lot of decisions and drive the overall roadmap there. So we did this first project with no concrete. So we used helical piles as a foundation system. So the zero excavation, we were able to do the foundation in the day, in the dead of winter in Massachusetts, which is a huge advantage. But also saved a ton on, literally saved tons on embodied carbon for the project. And then the other part we've been standardizing in our building platform, including our wall assembly, is how we think about all the insulation material choices. We're building to passive house performance. This first project actually is passive house certified. Certification we're debating on because a lot of our customers don't want to pay for the certification, but they want the same performance. So we're building to a passive house performance standard. This requires us to, right, we're effectively having to build a 10-inch insulated wall in the Massachusetts climate zone. Mm-hmm. And so here we use, surprisingly, recycled Amazon boxes, our wall insulation. So we work with a company called Clean Fiber. So they've been using a lot of Amazon boxes as a source of cellulose for wall cavity insulation. And then we've been using rigid wood fiber boards as our exterior insulation, and that's a carbon negative material. And great news here is we actually have a factory that's opened up locally in the area. It's called Timber HV, and they're going to start putting out these boards locally. The first project we ended up having to get this from Europe, but we have a robust local supply chain coming up there. And places where we don't have a superior choice, like gypsum's a love-hate relationship, right? I think every modular factory has enough things to say about it. The challenge we had here in the local market is Massachusetts and New England historically has been used to plaster finishes. So trying to get them plaster to drywall is an acceptable step, but trying to move away to something more aggressive, hey, like what if you had finished ply or some other material was a bit too much of a leap. So we've had to stay with drywall and finishing drywall. But even there, we've been able to specify EcoSmart drywall as an option, which uses 25% recycled gypsum in it. So we've been able to make material choices that also drive down the embodied carbon content of our homes. We also use cork flooring in this project. The jury is still out. It was a pretty challenging process in the factory. So we're still trying to see if we can find different ways to apply cork flooring instead. But we've been making material choices a little atypical for the industry, but we believe these are the right choices to make to drive the embodied carbon down, but also really build a high performance envelope.
You know, Vikas, I want to just make a mention on this, that wall assembly photo that's on that right-hand side there. For those that are watching, that is a very typical style wall assembly that you're going to see through Europe. I mean, this is a typical wall style assembly you're going to see through Europe. My last trip over this past year in Germany, Switzerland, Italy, they're all building this way, and it is a requirement over there to meet that net zero passive house standard, and even further than that in some of the countries. So when we look at this, this isn't new technology. This is just technology that we need to be using here to meet the standards that the rest of the world is already meeting in a lot of their construction builds.
100%. And I think the transition is already happening here. So Massachusetts adopted the 2021 energy codes, but also introduced a stretch code layer to it. So today, if you're building a 4,000 square foot single family home or a 12,000 square foot multifamily building, you have to be all electric, net zero ready, effectively meeting passive house requirements. So it's actually becoming very commonplace in Massachusetts now to see exterior insulation and then trying to look at 10-inch wall assemblies, right? So these are typically R30 wall assemblies, and we believe that's going to happen across the country as more and more states adopt the latest energy codes.
So I have another question I wanted on the wall panel slide that you had there. Can you ship the wall panels independently of a full module build for small infill sites, where modular is just not going to work, or you just can't get it in there, or it doesn't make sense?
We're definitely protecting for that future, and we're having discussions with one customer on at least just getting the exterior envelope done so they can get a passive house envelope. We think the future eventually, like all things being equal, if you could flat pack and ship a building panelized, like that becomes the superior option only if you can assemble it just as quickly as you can assemble volumetric modules, right? So we haven't cracked that code. Building codes today are very nebulous on can you actually ship an enclosed panel, right? Like we've heard enough stories from other players in the industry where they've had inspectors say, rip open the panel, I don't see a sticker on it that says this is approved. So we believe, like, I know NBI is working pretty heavily on trying to get panelized codes in place. Once that happens, we think there's a future to do that. Today, I think it's still, depending on the market, it's still pretty nebulous on can you actually ship a fully enclosed panel and have that not be an issue with the local inspector. So we want to protect for that future, but that's not what we're fully building upon today, because the labor efficiencies and productivity improvements we can get by controlling and consolidating all the labor in the factory is vastly superior an outcome than trying to build these piece by piece on site.
Got it. Thanks. I'll go back to your presentation.
Excellent. I think the last thing I want to say is also an observation, right? In addition to trying to standardize a building type, I think the other lesson for us observing the industry has been how do you create a diversity of product portfolio so that you're never really tied to any single asset class fluctuating, right? Like we're seeing a lot of pain in the multifamily industry today, and we've already seen a lot of this pain percolate, especially in England, with a lot of their product types. The business is drying up overnight. So we wanted to make sure that just from the get-go, we were building for a diversity of product types. And the product that we're finding actually meets really nicely for the microfactory construct as the missing middle housing. So doing infill, adding more density to existing lots, starting from the ADU that we just built. It was effectively a single family home that we zoned as an ADU. And then we're starting to productize a triple decker. We have 2 of these projects that are contracted. We're doing the design work now. They'll be breaking ground in Somerville, Massachusetts later this year, early next year. And then we've been surprised with this interest in duplex home types for communities out in New England. So that's an area we've gotten pretty excited about. And the product we've designed there can be built as a single family we've chosen, or can easily meet the zoning requirement for duplex. And we're pretty excited about that. And we have some interest in these garden style multifamily communities. So we're exploring further in how we can build up both the building platform for it and also the capacity in our factories to do that.
Right. So right now, what are you building currently? Are you just doing the single family home right now, or do you have the ability to do all of this?
We have the ability to build more of the single family homes. What we're currently productizing is the triple decker, and then we are in parallel productizing the duplex. So if customers have lots that they want to build these on, we can actually take orders for 2025. The multifamily product is the one that's probably going to be late end of 25, early 26 is when we'll be ready for it. And that's how we've been prioritizing our resources here on the design side.
Great, thank you.
And then the last thing, at least want to also highlight, and I think this is important for our industry because we've seen a lot of pushback from traditional construction is in embracing net zero energy codes and actually moving the industry forward and building homes that I think regardless of people's views on what climate change or what's causing climate change, the evidence is that climate is changing. The other piece is really clear is that our homes need to become more resilient. Right. And there are really established ways, and I think the modular industry can lead the charge here in building homes that are climate resilient, but also high energy performance that are actually really good for total cost of ownership for our customers. Mm-hmm. And we're also learning it's actually a lot easier for us to achieve those requirements from a factory-based construction model than to achieve it as on site. I think this video made a mistake, so I don't think we'll be able to play this, but the key part I want to drive was even for this first project that we did, we achieved a 0.47 air tightness rating for the project. And it's pretty hard to do, but we were able to do that out of the gate because of the precision we can achieve in the factory setting. What we've seen happen for a lot of on-site constructors is we're having to take remediation measures after the fact to achieve that air tightness. And to level set here for the audience, Massachusetts code now requires us to hit 1.5 ACH 50. It's already twice as tight as the previous standard, right? So the tightness requirements are increasing. And to hit passive house ratings, you need about 0.6 ACH, which is a really, really airtight structure. And we've been able to hit that with our panelized approach in the factory and the precision there. Right. And we believe that the modular industry can actually deliver pretty high performance airtight structures a lot more efficiently than on-site construction teams can. And I think we should embrace that as an industry and lead that movement.
Yeah. I mean, hey, listen, as my friends at SIGA say, to build it right, you got to build it tight, right? And that's just the way it is. What are you using for mechanical systems in these structures? Are you using mini splits, regular HVAC systems? Because when you build so tight, the transfer of fresh air becomes very important to allow the house to breathe as well as the occupants. So what are you guys doing to address that? And then talk to me a little bit about, is this a cost-effective solution? I mean, is this something people should be looking at because you can do it for what they can build site building for today?
Really good questions. Let me take the HVAC system first one. So for the first project, we actually used a ducted heat pump system. I think the lesson from that project was trying to go with ductless mini splits is actually a more factory efficient approach for modular, and that's where we're switching to for future projects. And on the air tightness and mechanical ventilation requirements, so we have an ERV, so it's an energy recovery ventilator. That actually used to be something you only needed to do for passive homes and to meet the passive house standard before. But even with the 2021 energy code, active mechanical ventilation as a requirement. So I think we'll see that more and more builders will have to start using ERVs as part of their builds. And it's been a fairly straightforward thing for us to incorporate into our systems. Yeah. And in terms of cost effective, sorry, go ahead.
Oh, I was going to say, for people out there that are watching this or maybe on the consumer side of this, an ERV is an energy recovery ventilating system. Basically, all it does is help exchange fresh air and filter out bad air from your home on a certain interval based on the size of the home, location of the home, et cetera. So I just wanted to clarify that.
Yeah, thank you for that. And I think it's also important to acknowledge that just having the mechanical ventilation, because it's also actively filtering air, there's been a couple of good studies on how these airtight homes are actually significantly healthier because of the indoor air quality is much better. I think this is going to become even more important as we start seeing, right? I think the annual events of wildfires encompassing, the smoke encompassing almost the entire country is becoming an annual occurrence now. And I feel like these homes are going to be a lot healthier for occupants. But end of the day, all of this only matters if we can bring costs down. I think that's the real question. And for us, the first project we did was obviously above our cost targets given as a first build. But where we're marching towards is we're trying to get to a $275 a square foot cost target, like a price target for our customers. Mm-hmm. And this is a pretty competitive price point in the Massachusetts market and the New England market in general. So for passive homes here, right, the market rate today for on-site construction is between $350 to $500 a square foot because they're all infill sites, pretty challenging to do. We've seen a pretty wide range. We've been able to hold steady on the $275 a square foot, and this assumes this is a triple-decker project about 4,000 square feet. For the ADU size, I think we'll still be in the $325 a square foot range, only because we're still doing a lot of the same work on a smaller footprint for the foundation. So we kind of take the cost penalty. But we believe we're pretty competitive for the market we're in today. The roadmap we're trying to get to is how do we get to an internal cost target of $100 a square foot by our second generation system? Because that is what truly unlocks a lot of the ability for us to get into other markets, right? Like we're not competitive in the Houston market today.
Right.
But that's if you want to be able to build in Houston or in Tampa, and to do that, we need to like drastically reduce our cost curve. And to do that, we also have to re-engineer our building system. Like I think trying to get to that cost curve purely with the system we have today is pretty untenable. So the thing the team's already exploring is right, the whole algorithm for what parts can we eliminate, right? So things we're already looking at are the wall assembly that you saw, right? It was 2x6 construction, right? Step for insulation, step 2 add drywall, step 2 add zip sheathing, step 2 do all the taping to get the water tightness right, then exterior insulation, then strapping, then cladding. So the goal is, can we start finding better suppliers and components that allow us to reduce the number of steps in, right? Like could we just bolt 2 components together and you get the same performance? So we're exploring those angles. We're keeping an open mind. We were shying away from mass timber and CLT only because we had sticker shock initially when we looked at just the surface level pricing. We got to spend a bunch of time in Europe with Modex in June. And there we also got to meet with a couple of US-based mass timber suppliers who are on the same bus with us. And they've opened our thinking where like a lot of the cost is actually in the finishing requirements that people specify for mass timber. But if you actually try to buy mass timber in bulk and get 3-ply or 5-ply CLT panels, and do your own finishing after, it actually becomes extremely cost competitive to a multi-panel structure. So we're keeping a pretty open mind to see how we keep evolving our building system so we can hit the $100 a square foot cost target. Sure. And we're pretty optimistic we can get there with our approach.
Excellent. No, I'm sure as you scale, it's going to get better and better. So we have, looks like we have one more slide left. Let me put this up for you.
It's, I think that might have been the last one actually, or it was my call to action. Like how do we unlock climate-friendly homes for all? And I truly believe that the offsite construction industry can lead the charge here.
Awesome. Thank you for the presentation. I'm going to go to a couple comments and questions that may be here in the chat. But I want to wrap up with, how do people work with you? How do people get their own microfactory? Are you allowing people to have their own microfactories? So we want to know what the future looks like working with Reframe Systems. But first, let's few hellos. Joel Hutchins. Hey, Joel, congratulations. I saw your post. You made another big move. Make sure you put in the comments where you're going, man. Joel's always been a big supporter of this industry as well as this show. So always happy to give you a shout out, Joel. One of the smartest guys out there. I'm telling you, if you don't know him, because you should. All right. Dr. Ranga, I think I'm saying that, Ranga Reddy Enti. Good afternoon, all. He says, great idea.
That's my dad.
That's your dad? Hey, Dad. Thanks for joining us today. Well, my guess is he's probably a pretty smart guy, and you must take after him because it seems like you got this stuff going in the right direction as well. So well done, Dad, I should say. All right, we got John Fay. Hey, John, man, it's been a while. I hope you're doing well. Good to see you out there. Hey, best solves in the industry, Steve Schrader, Hundegger. So is the concept just-in-time components, ? In other words, each part is cut as it is needed, ? We touched on this a little bit, but go ahead.
Yeah, so we're still doing just-in-time batching. So we're still pre-cutting all the lumber that we need for a batch of walls. So we still have some batch optimization there. And that actually allows us, I think there's also a question on nesting and optimization. And I think that's an advantage. Try to still pre-batch some of the cuts because we explored an option of we actually have the robot cut lumber so that we're actually giving it a pallet of uncut studs. But the challenge there was we very quickly realized we're going to be wasting a lot of material. So trying to pre-batch and pre-cut material in larger segments so we get to optimize for wastage, I think is the way to go, and that's where we are.
Excellent. Appreciate the comment and question. Good to hear from you, Steve. Henry Mickelberg says, I would like to see your cost and time comparison between robots and humans for all the variables before I begin to entertain. Henry, thank you so much for the question. And he is no stranger to optimizing factories around the world. So it's a great question if it's coming from Henry.
Yeah, I think it's a really good question, and I think that there's two perspectives to this, right? I think if you're taking the perspective of, do I need to buy robotic automation today to get better ROI in my factory? That calculus will really require to make sure that you can actually get the time comparisons right. But if you change the question to, do I have a better opportunity cost in how I scale my network of factories, where it's actually easier for me to replicate the robotic work cells than having to keep hiring additional workforce every time, and that workforce is going to be hard to find. I'm willing to bet time and again that the robotic work cell is going to win when we're having that conversation 5 years from now. And this is something we realized even through the Amazon journey, was eventually we're like, we just couldn't hire enough people. And right, that was where, so this is where we're making the long-term bet. Like absolutely today, we can still have a build team build a wall panel faster. But the goal is we're building this entire system, not just for today, but to make sure it can actually keep scaling. And to do that, we know that systems that scale are the software systems and automation systems. And that's the bet we're making, so that if we have 2 carpenters or 2 builders in the on staff, would I rather have them go back and frame a panel and do a repetitive task, or would I have them do something that requires more craftsmanship on the finishing side instead? Our carpenters want to do the craftsman stuff and actually be on the finishing side. And that's where we want them to be too. So we'll keep finding ways to automate the dull repetitive tasks. And right, the ROI play is actually going to make sense, a lot more sense at scale. And I think we're building for that future.
Great question. Thank you. Even better answer. All right, let's go. Joel back. Question, are you delivering on site, and how does your OS helo there?
Hey, Joel. Yeah. So today we're still partnering with a few different subcontractors to help make sure on the delivery and set. But a key part of our Microfactory approach is that we are the prime contractor. So we're effectively taking care of manufacturing, design, but also we are accountable for the on-site outcome. And we still think that the answer for coordinating transportation and for coordinating on-site work, right, I think still falls on us, but we'll still always use delivery partners to help us with it. The piece of the software we want to build out is the same workflow we have in the factory we're trying to build out for the field on how do we make sure. I mean, the first project was too small, just 2 boxes, the order was obvious. For the triple decker, we're trying to get 18 boxes in there. How do I make sure that we have instructions on site for the order of operation, how the boxes get in, but even the on-site stitching work. So we're trying to get the same factory interface into the field to take care of it. The logistics piece today for us is a little simpler given the scale of operations and the delivery radius we're working on. But imagine that's something we'll have to take a closer look at as we scale.
Excellent. Excellent. All right. We got time for 3 more quick questions here. Hey, look at that. Peter D. Maria, one of the smartest architects on the West Coast. In fact, he almost wrote all the codes for offsite modular construction when he was doing container builds back in the day, now with mid-rise modular. Peter, man, it's always awesome when you join the show. Thanks. He says, how many units have they delivered in the past year?
Hey, Peter, we just delivered our first project, and we're currently working on 6 units, and we have work in the pipeline that'll hopefully get us about 30 units of housing we deliver in 2025, and then we continue scaling from there.
Excellent. Peter, thank you so much. All right, 2 more questions. Back to Henry Mickelberg. Henry, I'm surprised I didn't get a book from you today, but I won't hold it against you. Question, given the unique wall buildup, what fire testing do you have?
It actually is not a unique build-up. Like that's the standard tested assembly. So if you look at the assembly from drywall to the zip, like it's a pretty standard wall assembly here. And then the exterior insulation, the insulation itself is fire rated. And we add rain screen before the cladding, which allows us to also make sure we've got the necessary venting that's needed there. So as far as I understand, this is a pretty standard assembly here, and we haven't needed to do any additional work on it.
Great. Thank you for that, Henry. All right. Hopefully I say this right. The Toolbot, I believe is how we say it, from YouTube. Fantastic presentation. You're doing great work, Vikas. And I think he has a follow-up here as well. I think the idea of shifting more of the work from craftsman orientation to software is the key to potential future standardization across the value chain, supply chain. Reframe mainframe sounds good. I kind of like it too. Reframe mainframe. Why not?
All right, let's do that. Then I think my engineering team will be really happy with that. So,
and I just got to put this up because Henry is a bit of a snarky individual. He said, perhaps I should find ways to automate my dull and repetitive questions. Hey,
ChatGPT.
That's it. All right, Vikas, we're just about out of time, but I want to get to these questions. How do I work with you? How does anybody else work with you? How do I start my own microfactories? Is the goal to, grow this yourself, or are you looking to have partners or franchises?
Our goal is to keep finding partners. Today, we're partnering with developers and sometimes retail customers to help be their design build provider and build and get you a home or build you a suite of homes. I expect that once we've built a lot more cycles of process optimization in the factory, that's when we start replicating our factories and productize that up to scale. The same way Amazon opened up AWS and unlocked a lot of Amazon's internal tooling to external players, we will most likely follow that playbook where we're initially starting with our own products that we're designing, building, delivering to you. Over time, we want to open up Architect parts so that you as an architect can design your own building using Architect systems. And then we finally open up our factories where we can also either directly sell the factory to you or build, own, and operate the factory on your behalf as a customer in any location that you would like. So this is an evolving conversation for us. And if you have other ideas on how you'd like to partner with us, please reach out to us. I think the details are being solved in here.
Excellent, excellent. There is a question that did not come up on the show notes here, but Jennifer was kind enough to send it to me from Arash Shakari, CEO NetZero Modular. He says NetZero title comes through testing, and a real NetZero building has third-party qualified verifier.
Yep.
Yep.
Yeah.
Perfect.
So I mean, we're working with so we're meeting the FIAS0 certification. We're working with the third-party HERS rater, and we have a third-party passive house consultant who's effectively validating everything from design energy models to the final build. So.
Yeah, and we talked a little bit earlier about that as well. I just didn't want them to think that I missed it. Andrew Sealy, I saw you commented as well. Thanks, everybody, for joining. Vikas, have I missed anything? Is there anything that you want to make sure everybody knows before we wrap this up?
I think we covered it all. I think I'll just say this one more time. We need to build more net zero homes, and I think we're all part of this larger movement. If there's anything we can help in sharing the lessons we've learned, we'd love to do that. And yeah, let's keep building, and let's build better homes that are better for the planet and for people.
Well, guess what? Know who else wants to build better homes, Vikas? The International Code Council, the ICC. That's right. On October 20th through the 23rd, 2024, we are inviting you because Dave Cooper Live is now a partner. That's right. The offsite industry is a construction talker, influencer, whatever they call me out there, is partnered with the ICC to bring all the professionals to them. It's coming up October 20th through the 23rd, Long Beach, California, for their 2024 annual conference, expo, and committee action hearings. So you definitely want to join that. And I hope, Vikas, you and your team come out there, because this is going to be an opportunity for the industry leaders to sit down with the people that are behind helping us write better codes so we can all build it easier and we can build to a manufacturing standard versus a site built standard. Sounds like a great time to me. I don't know about you.
We'd love to be there.
Excellent. Excellent. Hey, Vikas, don't go anywhere. I'll come back to you after the outro. But for the rest of you out there, thank you so much for joining us. Thank you for all the comments, likes, and shares. We do appreciate you out there. And also a big shout out to these supporting members and sponsors as well. I'm Dave Cooper. Thanks for watching.
What an amazing show. Thank you to all of our sponsors for helping us to continue to bring all of these innovative conversations to all of you out there. Please visit them, see what they have to offer you. And as always, subscribe to the YouTube channel and ring that bell. It would mean the world to us. I'm Dave Cooper. Thanks for watching.